Assalamualaikum. My name is Muhammad Ahmad Faris bin Arafas. My metric number is 2212645, and now our group is going to do the presentation on our microprocessor project. And our project is similar to how traffic light works.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faizudin bin Zulkifli, and for this project, we will be doing a simple traffic light system in which three different lights will take turn in turning on in a specific span of time. So firstly, we must define a few things. The first thing we must define is the output, which will consisting of the three colored light, the red, yellow, and green, to the PD2, PD3, and PD4 respectively. We are now assuming we will now define the clock frequency to 16 megahertz, and then we will set the origin of two subroutine. The first one being the init subroutine placed on the 0000 hex, which means it will be the first thing that is executed. This is the first instruction that will be executed when the system reset, and then we set the origin of time overflow subroutine at 0018 hex, in which the time overflow will function as an interrupt vector. It will function as an interrupt vector for the system.
Okay, so for this part of the code, what it does is that it initializes the stack pointer by loading the low and high bytes of the RAM and address into register R16 and then storing them into the low and high registers of the stack pointer respectively. This sets up the stack pointer to the top of the available RAM space. And then continuing, this part is what it does is that it configures the pins connected to LEDs, presumably port D, as outputs. The bitwise or operation is used to set the corresponding bits for the red, yellow, and also for the green LEDs in register R16, and then the result is written into the data direction register DDRD using the out instruction. And for this part of the code, it configures timer 1 with a prescaler value of 1024. It uses the LDI, which is load immediate instruction, to load the low and high bytes of the timer counter control register B, which is TCC R1B, address into the register pair R13 and R31, which is also known as Z registers. Then it loads the prescaler value bits CS12 and CS10 set into register R16. Finally, the SDS instruction or the stores to SRAM instruction writes the prescaler value to the TCCR1B register. Note that the address 0 times 0 in SRAM is used, which corresponds to the low byte of TCCR1B in this context.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafi bin Azman, metric number 212983, and now I will continue the presentation of this project. So now I will explain how to enable the timer 1 overflow interrupt. So the first line is LDI R30 low 0x6F, which will load the low byte of the timer interrupt mask register 1, which or TIMSK1 address into the register 30. The next line is LDI R31 high 0x6F, which will load the high byte of the TIMSK1 address into the register 31. The next line is LDI R16 1 less than TOIE1. This instruction will set the register 16 to enable the timer 1 overflow interrupt. The next line of instruction is STI TIMSK1 R6. This instruction will store the value in the register R16 to the TIMSK1 register, which will enabling the interrupt. The SEI instruction will just enable the global interrupts. The next instruction is main loop, and under the main loop will be rjump main loop. This instruction will create an infinite loop that keeps the programming running. That's all for me. Now I will pass the presentation to the other presenter. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Ahmad Adam. My metric number is 2219973. And today I will be presenting the last section of our code. So in our project, we use timer overflow, which acts as a stopwatch. It tells us when it's time to switch our traffic lights, in this case our LEDs. And the first step in the cycle is by turning off all the LED, giving us a clean state to start the sequence. And next, we program the sequence of the lights. We set it up to follow the family pattern of actual traffic lights, starting with green, yellow, and then finally red. And next, we have our delay function. The delay function is very crucial as it determines how long each light is on. And for realism, we've also made it that the green and red lights linger a bit longer than the yellow light, just like the real one at the intersection. And to sum it up, our code used the microcontroller's built-in timer to neatly cycle through a traffic light pattern mimicking what we see on the streets every day. After this, you will see our demo for the project. Thank you.